itself, and you can see that these are identical. And furthermore, if we ask, is tool to call actually multiply, it's true, right? So all that to be said, again, we're exploring kind of the low-level process of how a tool actually would get invoked, and we've shown that the information from the LLM tool call response has sufficient information that after taking a few steps, we can actually arrive at a tool to call that can actually be invoked, which we'll demonstrate here, right? We know we have the arguments, we have our tool to call. If we invoke it with the arguments, you can see that it works, and we could actually invoke it more specifically with what we asked for, just to prove that it worked as expected, and you can see that it does. Okay. So, that was a lot of detail, and we own that. But we wanted you to understand what was going on under the hood, especially because we're going to provide you with a following function, which is going to expect a model response. And if there's a tool call, go through the process we just walked through to actually invoke the tool with the LLM supplied arguments, and then return the result of the actual tool invocation. In the case that an LLM didn't indicate a tool call, then the function is simply going to return the content of the model's non-tool call response. Okay, so this is basically an encapsulation of what we just went through cell by cell. It's going to be called call tools. It expects an LLM response. If the tool calls property on the response is an empty string, then we will simply return the content. Otherwise, we're going to establish a mapping of the tools we know we've provided to the LLM. And this is the process we just underwent. We will get the tool call off of the tool calls property. We will get the actual name of the selected tool. Using the tool map, we'll get the actual invocable selected tool. We will get the arguments, and we will return the result of invoking the selected tool. Okay, so now that we have a function for calling tools that expects an LLM response, it makes sense that we can create a chain where we will use the LLM with tools and pipe it into a runnable lambda of this function that we just defined, thereby taking the response from the LLM and piping it into our call tools function. Excuse me. Okay, so we'll begin by invoking it with a prompt that has nothing to do with any of the provided tools. And you can see we would expect, in our function here that because tool calls was not present, we just returned response.content, which is what we see here. And now we'll try it with some multiplication. You can see we got a number back, and if we look using Python, you can see that it would appear that it used the tool to give us the actual result of that number. And then let's try instead to ask it for something that involves addition. And you can see in this situation also, it was able to utilize the add tool to use Python to come up with the correct value of adding these two numbers together, which we confirm here by literally using Python to get the same value. Okay, so it's a good time to point out that, as with anything with large language models, tool calling, you can't just assume that it's going to be perfect. So let's make this problem a little bit more difficult to kind of make our point here by providing it another addition problem to perform. But rather than providing the actual numbers in our prompt, we're going to use natural language. So, what's 9,012 plus 13,363? Okay, so let's invoke it. We got a value back, that's good. But if we look here at the actual value from using Python, you can see that there's a discrepancy. Okay, so let's see here. In this case, let's look at the tool calls property. Okay, so we're going to invoke it again with our same prompt, but we're going to look at the tool calls property off of that. And what we can see, if we look at the args field here, is that the model set A equal to, 9 million instead of 9,012. And because of this, right, this resulted in the add tool adding the wrong two numbers and therefore getting the wrong result. So a few takeaways here. One is when you're using tool use, right, you can and should introspect the args that it's actually providing to the tool when you find something is going wrong. And furthermore, even though tool call is powerful and can supply our applications with functionality that an LLM is not well suited to, we have to take all the same considerations that we have been throughout this workshop regarding hallucination, accuracy, being concise, being precise. All of these factors are still at play, right? There's no magic that's happening with tool calling. It's all prompt engineering and model responses under the hood. Right? Okay, so now that we have a way to create tools, now that we've shown you a naive but functional way to get the result of an actual tool invocation, we'd like to have you give this a try in an exercise. And for this exercise, you're going to be using an external API, namely the Wikipedia API. And this is a very common place to use tools in LLM applications. LLMs obviously are unable to send requests to external services. So if we want our LLM to be able to do that, then we need to provide it with a way to do that. And we're going to do that via a tool here. So the following function called get Wikipedia intro, you can largely ignore the details of this function. It doesn't really matter if you understand it or not, but it's just using the Wikipedia API library that we imported at the top of this notebook to make a request and on a given topic, which should be a string that will provide it. And this function here, get Wikipedia intro, will either get the first paragraph of the topic's Wikipedia summary, or will return a message that no Wikipedia page can be found for that given topic. Okay, so this is a Python function. Take my word for it, it works. You can try it out if you want. But here's the goal for the exercise. We want you to create a tool out of this, right, to augment an LLM. And what this will do is it'll allow your LLM to use the tool whenever it is asked about a topic that is too recent for it to actually know anything about. So, as you know, large language models are trained on a lot of data, but depending on how old a large language model is, it will not have access to information on very current events. So we'll assume for the model that we're working with here that it was trained on data through 2022. So the idea is we want you to be able to use this get Wikipedia intro function to obtain information from Wikipedia if it's given a prompt asking about something more recent than 2022. Okay, so here's the approach that we recommend you follow. First, you should create a tool out of the above function and be sure, as we've shown in this notebook, to give it an explicit use case for it in its schema. You're going to need to bind the tool to your large language model. You're then going to need to construct a chain with your tool bound LLM and a custom runnable that will be made out of this call tools function, which we're providing for you. This is identical to the call tools we did above, except we went ahead and created a new tool map that expects the get Wikipedia intro function as an available tool to your large language model. And then as a final step, to check your work, you should invoke your chain with a prompt about something the LLM itself could not actually know about. We recommend, for example, information about the 2024 Summer Olympics. This is information that surely the large language model was not actually trained on, but also we know that Wikipedia has information on the 2024 Summer Olympics. Okay, so please give that a try. And when you're done, you can come back, unpause the video, and we'll take a look at how we approach this in the solution. Okay, good luck. Okay, there was quite a few steps for you to undertake in this example. Hopefully you were able to figure most of it out. Here's an approach that worked well for us. We know that we have this get Wikipedia intro function that we want to decorate as a tool, so we are decorating it with the tool decorator. and providing it in args schema using a Pydantic class, which we define here. For our docstring, which as you know is an important bit of prompt engineering, because of the exercise guidelines, we said that this should be used to look up information for events that happened after the year 2022. And we indicated that the topic is a required string field, and it indicates a topic to get more info about. No modifications to the get Wikipedia intro function. This is exactly what we have provided above. We've just decorated it. So now that we have a tool, we can create a new LLM instance, which again, we're calling LLM with tools, and we are binding our get Wikipedia intro tool to it. One thing to note is even though we're only binding a single tool, bind tools always expects a Python list, so we have to provide a single item list. We will now create a chain, just as we did above, that takes LLM with tools and pipes into our call tools function. And in this case, if we ask for a short summary about the 2024 Summer Olympics, you can see that we successfully got back information on the 2024 Summer Olympics. And we could introspect this further if we wanted to, but this is actually the first paragraph summary from Wikipedia that the LLM was able to recognize, it ought to use, it suggested the API call, we made the API call, and this is the actual response from our get Wikipedia intro function. Okay, so in this notebook you learned how to create tools for tasks that either an LLM is not well suited for or is impossible for it. And furthermore, you got to see the results in a very naive chain of actually invoking the tool. In the next notebook, we're going to introduce a topic called agents. And agents are a much more powerful and also sensible way of orchestrating tool use. It's going to allow your models to reason about tool use, and maybe most importantly, to actually provide the results of actual tool invocation as inputs